The exhaust system of the FPT N67 can be very complicated at times and needs additional explanation on top of what we've got in our basic presentation. Before you is a flow diagram showing how the basics of how the intake air and exhaust is in the system, moving from the air filter to the turbocharger compressor, out to the intercooler, into the cylinders, and then back out to the turbocharger, and then out to the muffler and emissions equipment. The exhaust manifold is located on the top side of the cylinder head and directs flow from the exhaust port of the head to the exhaust inlet on the turbo. On the T7-315, it is in a very difficult location and requires many components to be removed to access it. The N67 is not equipped with an EGR valve, an EGR cooler, or a diesel particulate filter due to its HIE SRT2 aftertreatment system, which complies with federal regulations for emissions without any of these. The diesel oxidation catalyst, or DOC, has a cell structure that exhausts flow through. The surface is a layer of aluminum oxide, which is platinum and palladium, and these metals provide for the oxidation of the exhaust gases. In turn, this reduces carbon monoxide and reduces the amount of unburned hydrocarbons. It is a required component to achieve as possible to a 50-50 ratio of nitrogen oxide to nitrogen dioxide before the SCR. The selective catalyst reduction system is a very large, complicated system within the emissions and has many components. The first is the ECU, which controls it, the exhaust flap, the intake air humidity and temperature sensor, the air filter, the NOx sensor, the pipes for the DEF level and temperature sensor, the DEF quality sensor, the tank, the coolant level valve, the dosing module, the DOC, the SCR upstream temperature sensor, the SCR downstream temperature sensor, the NH3 sensor, another NOx sensor, the engine, the supply module, the DOC, the SCR muffler, and the cleanup catalyst. The system requires coolant from the engine, DEF, to function, along with electrical inputs from the ECU. The catalyst serves as the exhaust muffler as well as the device to remove nitrogen oxides, or NOx. All engine exhaust flow passes through the SCR catalyst. Urea-based diesel exhaust fluid reacts with the higher concentration of NOx caused by the combustion cycle. This chemical reaction converts the NOx into nitrogen and water vapors, which exit through the exhaust pipe. For it to function, the temperature of the exhaust must be at least 446 degrees Fahrenheit to function. One of the components that require additional explanation is the exhaust flap. It is located in the exhaust plumbing at the outlet of the turbocharger and is controlled by the ECU based on the inputs from the DOC and SCR. It restricts the exhaust flow and places a load on the engine, which elevates exhaust temperatures and will maintain proper exhaust temperature for NOx reduction. It requires coolant to cool the exhaust flap actuator. Another component within the SCR is the cleanup catalyst, or the CUC. It removes excessive residual ammonia, or NH3. Excessive ammonia reacts with the CUC and oxygen, and then it is converted to nitrogen and water vapors. The target is to lose less than 10 parts per million of ammonia out of the exhaust pipe. This exhaust system, combined with the other technologically advanced engine components, make for an efficient and clean engine that meets or exceeds current EPA standards.